here we are with the module 2 of the chapter 1, that is errors in measurement. So let's begin this module. First of all, we will talk about what is error. Watch here. Here is a wooden bar. The length of this wooden bar is 11 inches. This is the true value or the true length of this wooden bar. But when this wooden bar is given to the two different students, what happens? Watch here. This wooden bar is given to the first student and it is given to the second student. The first student measures it with the help of a ruler and tells that the measurement is 11.01 inches. Now the second student measures the length of the wooden bar and tells that the measured value is 10.99 inches. Now these are two different values observed by two different students. Alright, so 11.01 inches and 10.99 inches, these are the measured values by the two different students for this wooden bar, of which the true value is 11 inches. Now watch here. The true value is 11 inches and these are the measured values. Watch here. The measured value for the first student is 11.01 inches. The measured value by the first student is 11.01 inches. We can write it like here, and the measured value for the second student is 10.99 inches. All right, now watch here. This 11.01 inches can be written as this 11.0.01 inches. Now watch here. The deviation between the true value and the measured value in this case is this 0.01 inches. The true value is 11 inches. The measured value is 11 plus 0.01 inches. So this 0.01 inches is the deviation between the measured value and the true value. So this is the deviation, 0.01 inches. And in this case, this 10.99 can be written as 11 minus 0.01 inches. All right. So, and here the deviation is 0.01 inches. Why this is here? All right, watch here. This is the true value, that is 11 inches, and the measured value is 11 minus 0.01 inches. The deviation between the true value and the measured value is again 0.01 inches. The deviation could be in positive or it can be in negative from the true value. Here it is plus with the true value, here it is in minus with the true value, but there is a deviation. All right, the deviation between the true value and the measured value, the deviation between the true value and the measured value. Okay, and these deviations are called error. This deviation is called error. So we can say that the deviation of the measured value from the true value is called error. All right, now for the length of this bar, for the length of this wooden bar, the measured value is 11 plus 0.01 or 11 minus 0.01 inches. So we are combinedly writing it like 11 plus minus 0.01 inches. The measured value for the length of the bar is 11 plus 0.01 inches. All right, it can also be written like measured value is equal to L plus minus delta L. This L is the true value and this delta L is the error in the measurement. All right, where L is the true value and delta L is the error in the measurement. So this measurement can also be written like L plus minus delta L. Okay, moving ahead, we have types of error. What are the types of error? Let's discuss. There are mainly two kinds of errors. First one is systematic errors and second one is random errors. So what are systematic errors? What are random errors? We will discuss here. So moving ahead, first of all, we will discuss systematic errors. What are systematic errors? Let's discuss. All right, the errors associated with the faulty equipments are called systematic errors. Systematic errors, it is clearly shown by the name of this, that systematic errors. Systematic means the errors must be in the system. The system are the equipments, and equipments are faulty. When the equipments are faulty, the errors associated with these faulty equipments is called systematic error. All right. Now, these are further classified as, the systematic errors are further classified as instrumental errors. What are instrumental errors? Watch here. The error due to defective alignment of the instrument is called instrumental error. What is defective alignment of the instrument? We will see here, and that must be categorized under instrumental errors as a subheading of the systematic errors. So what is defective alignment? Watch here. This, you can see here an ammeter. This A represents that this scale belongs to an ammeter, and this is the condition where no current is supplied, to the ammeter, and in this condition this pointer must be at 0, but this is not at 0, this is under 0. That is called the defective alignment, of the instrument. So you can clearly see here, this is the pointer is under 0. This must be at 0 when there is no current in the ammeter. So this is called defective alignment, and it is categorized under instrumental errors. Moving ahead with some more. The errors due to imperfection. What are imperfections in the system? Watch here. The errors due to the fault in the apparatus used in an experiment. If you are using an apparatus in the experiment and there is a fault in the apparatus, there are connections which are loose, or there is missing of any equipment that is required with that apparatus, or any fault in that apparatus if found, then the errors will be categorized under the errors due to imperfection. All right, now moving ahead, we have some more, that is gross errors. This is the kind of the systematic errors, the gross errors. What are gross errors? Watch here. The errors due to the improper adjustment of the apparatus are called gross errors. Okay, so your apparatus is in good condition, but the adjustment of the apparatus is not in good hands. Then what happens? Then the errors arise. If you are not adjusting the apparatus in the correct manner, then there is the possibility of the errors, and that error is categorized under gross errors as the subcategory of the systematic errors. All right, so moving ahead with random errors. Now, what are random errors? How can we define when random errors, or it can be defined or not can be defined? Watch here. The sources of random errors cannot always be identified. So it is clearly seen that the sources of random errors cannot be defined or identified. So what are these random errors? Why these are not identified? We will discuss here. So moving ahead, yeah, the possible sources of random errors are as follows. Watch here. The possible sources of random errors. What are the possible sources of the random errors? Watch here. These are environmental errors. What are environmental errors? Subcategorized under random errors. Watch here. The unpredictable fluctuations in line voltage, temperature, or mechanical vibrations of the equipment cause environmental errors. Okay, suppose you are performing an experiment, but there are fluctuations in the line voltage. You are dealing with the electricity, that apparatus or the experiment that you are dealing with requires electricity and there are fluctuations in the line voltage, then what happens? The readings, the observations that you are getting from the experiment, there would be some errors in those readings or the observations. Why? Because there is a fluctuation in the line voltage, and for the experiment we need a constant voltage. All right, in the specific conditions there will be needing a varying in the voltage, but in all the experiments generally there is no requirement of the fluctuations in the voltage. So if there is a fluctuation in the voltage, there is a possibility of the errors in your measurement or in your observation. Okay, there can be fluctuation in the temperature. Okay, if you are requiring the constant temperature, but due to the environmental conditions there is a change in the temperature, then your readings might vary. As in case of the Ohm's law, the required condition is the constant temperature. Only at the constant temperature the Ohm's law is applicable. If the temperature is not constant, the Ohm's law will not be applicable, or the readings observed at varying temperature for the Ohm's law will not be correct. There will be some errors in the reading or the observation achieved for the Ohm's law if the temperature is varying. Now, mechanical vibrations. Okay, if you are performing an experiment and there are mechanical vibrations within the object or outside the object, then what happens? The readings or the data you observed might be incorrect. So we have to avoid or reduce these fluctuations in the voltage, in the temperature or the mechanical vibrations to get the correct readings and to reduce the errors. All right, and these kind of fluctuations or the vibrations cause environmental errors. Moving ahead, we have observational errors. What are observational errors? It is clear by its name. These are the errors in judgment of an observer while reading the scale of measuring device are called observation errors. Okay, if you are reading the scale, or as we have discussed about the ammeter has the scale on it, the galvanometer has a scale on it, the voltmeter has a scale on it. If you are observing or reading the scale of measuring device and there is the error in the judgment of, or the error in telling the reading by the observer, then that error will be categorized under observational errors as the subcategory of random errors. So if you are having the mistake in reading or the recording the data observed from the scale of the measuring device, then there is a possibility of the error that will be caused due to the wrong judgment and will be categorized as observational errors. Now moving ahead, we have some methods of minimizing the random errors. So what are these methods of minimizing the random errors? We will discuss here. Watch here. The first one is mean error. All right. The random errors can be minimized by taking mean of the readings in an experiment. So this is one of the methods that can be used to minimize the random errors. Okay, so what we have to do, we have to take the mean of the readings in an experiment. In any experiment, we take some readings, and these readings are the number of readings, 4, 5 or 6 or more than 6. Okay, so we will take the mean of them to reduce or minimize the random errors. How to take the mean? Watch here. If delta L1, delta L2, delta L3 and delta Ln up to so on and delta Ln are the errors in the measurement, then the mean absolute error. How to find the mean absolute error if these are the errors in the measurement from delta L1, delta L2, delta L3 and so on delta Ln. These are the errors from 1 to n observations. Then how to calculate the mean absolute error? Watch here. This will be calculated as the modulus of delta L1 plus the modulus of delta L2 plus the modulus of delta L3 plus and so on plus the modulus of delta Ln divided by the number of observations. This is the way how we calculate the mean. All right, to calculate the mean, what we do, we sum up the entities and divide by the number of the entities. So these are the entities, delta L1 plus delta L2 plus delta L3 up to so on delta Ln, and this is the number of entity, that is n. We have summed up the entities and divide by the number of entities to get the mean absolute error. All right, this is the way we can reduce or minimize the random errors in the measurement. Okay, so moving ahead, we have relative error. What is relative error? Watch here. The ratio of mean error to the true value is called a relative error. As we have calculated the mean error, we will divide this by true value. When we divide the mean error by true value, what happens? We get a relative error. All right, the relative error is given as the ratio of the mean absolute error and the true value of the measurement. All right, the relative error is the mean absolute error divided by the true value. So this is one more method of minimizing the random errors. All right, moving ahead, we have the percentage error. All right, what is percentage error? Watch here. The relative error multiplied with 100 gives percentage error. As we have already calculated the relative error, this is the delta L upon L, bar delta L upon L. This is the relative error. When we multiply this relative error with 100, what we get? We get percentage error. So the relative error multiplied with 100 gives percentage error. This is the formula for percentage error. In so many numericals, we will be needing this. We will be needing to calculate the percentage error. Right? So these were some methods of minimizing the random errors. So that's all for now. See you again. Thank you.